open up to questions. I have to start one, having been involved with a big company and very innovative, forward, not as innovative as yours. You're going quite tetherless, but Markus or Stefan, when is it going to be ready? And the second question is, if it doesn't work, if you need to make it bigger or faster, is it scalable?
Well, thanks for this introducing question, Rick. Thank you. Well, as I said, the tower is prepared. My CEO recently called me, Markus, the shafts are done. So on Friday I'm there checking them, and we want to have the system running at the end of next year. And you will be able to see it when we open this tower. At that time, we will not yet be able to sell it to the market because, of course, the certification is quite a long process. We are already in connection with notified bodies and the process we want to follow, because this is quite a challenge, but it will be ready soon.
Okay, there's microphones around. Questions from the floor? Just one.
Very quickly, what of the innovations you've talked about can be used in existing buildings to improve them rather than a brand new building that might be built in the future in the next few years?
Well, to be honest, we have sold port technology, and therefore by extension my port, probably over 50% into an existing building. The trick actually is to make the transformation without 2 years of misery shutting down elevators. And we figured out a way to do that. What we actually do is we can put the system on top of the existing system while the elevators are all running. On one day we'll come in, we'll switch it to the new technology, the performance level will go up dramatically. Then if we need cabins to be refurbished or drives to be changed, we can gradually do that one elevator at a time. And yes, it will reduce a little bit the performance, but it's already much higher than it was before. So in terms of driving the elevators in a new way that gives much more efficiency and benefit, yes, we can do that. And we like to do that, by the way.
So I don't know if your question applied to only vertical transportation, but definitely in the world of structural design, by using high-strength steel in existing buildings, you're sometimes able to have more simplified solutions. Oftentimes you're limited on capacity of your existing buildings, so high-strength steel being a lighter weight alternative can bring a lot of value to those types of designs where you might not have to reinforce the existing system, or you would need less reinforcement than other applications by going with high-strength steel.
My name is Kenneth King. I'm a retired architect, and in my retirement, I wrote a book. And the book is about how to solve the problem of the urban problem that we have today. And my concept is to build a building as high as a mile high, about 400 stories. And to move the people around in this building, we have to have ropeless elevators, or the even the even the carbon fiber elevator is not going to work too well. So I'd like to ask a few questions on the ropeless elevators, because without it, my book concept will go out the window. and the question is, what are the difficulties in the development of this vertical, of these ropeless elevators? And the second question is, how can we expect the ropeless elevator to be commercial? When can we expect the ropeless elevators to be commercially available? And the third question is, what are the limitations of the ropeless elevators? And the last question is, sorry. Oh, I'm sorry. And the last question is, what are the advantage of this and disadvantage of the ropeless elevators as compared to the conventional elevators, such as the actual construction cost, the maintenance cost, and the energy consumption of the ropeless elevators?
Should I take these 4 questions?
I know Ken is an author, and his passion is the solution for urban China, and it's not a small question. We have ghost cities with empty 60-story buildings, stressed infrastructure, and it's not about form or ego in Ken's case. He's a many urbanist involved in this question, and together, I think there's a contribution to it. So his questions are not random, not incidental.
Yeah. So thank you for all these questions. Actually, these are the core questions why we are doing multi. I think the third question was, is there a limit for this system? No, there is no limit, and that is the main goal. The elevator industry is limiting building developers and how buildings can look like. Ropes, suspension means they are somehow limited to height, and we face a lot of problems with building sway, rope sway, and therefore we decided to have no limits. We want to get rid of these suspension means. And so mainly we address, of course, high-rise, mega tall buildings, super tall, mega tall buildings above the 300 meters mainly. Because there it shows the main advantages. Because there's no doubt that such a system is more expensive, but will pay off the higher you go. And as Stefan showed, especially for the traffic concept, the handling capacity or the waiting times, this is constant. No limit in height and shape, that's our goal. There have been a few more questions. I'm not sure if I got all of them. But I think this was touching the main points. And of course, if you want to go in more detail, I'm happy to be at our 3D simulation afterwards for further discussions. So happy to meet there. I also have my colleagues here in the back, Karl Schölkopf and Jörg Müller. They are in contact with consultants and building planners to answer questions to you more detail as you have it.
Hello. First, I want to congratulate you on a wonderful system, but my question is, in the development of the linear motors, have you had a chance to look at curved linear motors or twisted linear motors? And what is your progress there? Because right now I notice it's a mechanical system going from horizontal to vertical. If you had a smoother transition, that may expedite the traffic movement.
Well, thank you very much, Fritz King. We are in close contact because you're also a very good innovator, and I appreciated your speech 3 years ago on the articulated funiculator. Your question I just got from my colleague yesterday, and Jörg asked me, can you do it in curves? It's fascinating how many ideas we are creating with multi. I never expected that. Just going beyond what we think so far. To be honest, at the moment we are not thinking of a curved linear drive because on the car we do have the passive magnet yokes. And so this has a certain length, about the height of the car, so about 2.4 meters. And of course there's a small air gap. And to make this curved, I do not have an idea yet. So thank you for giving me something to think about, but it's not on our master plan so far.
Other questions. I have one for Shelley. As Ken talks about a mile-high building, I hear the structural engineers saying, wait, wait, wait with concrete. And will we see more steel coming back in with lightweight?
Well, obviously, that's the hope, is that steel will be used more frequently in that type of construction. Recently, there's been an introduction of 80 KSI steel for structural shapes in hopes of kind of grabbing onto that market share again, because with the high-strength steel, obviously, you can reduce the weight quite significantly, and it's a very cost-effective alternative. In addition, by using steel shapes, you also get the benefits of more floor area in the building and the concrete elements not taking up as much space. There's also solutions, those are just solutions with the columns. Also with beam sections, there are castellated beam solutions and things that can also give you a more efficient structure that's lighter weight as well. So all of these are out there on the market.
Okay, thanks. Okay, I guess that's it. One more question. Same.
I'm just curious, Shelley, when it comes to, this whole competition between steel and concrete structures. It was steel in high-rise buildings, and then it now has switched almost entirely to concrete. Do you see a way that steel's ever going to make a comeback in order to compete with the stiffness of concrete and the ability to do these 1:24 slenderness ratio buildings using concrete?
That's a really good question. Obviously, if there can be a steel section that has a higher E than other steel sections on the market, that would be a great solution. But outside of that, I think having exoskeletons and outrigger systems and really grabbing onto the perimeter of the building makes steel a very viable solution. And then beyond that, steel also has an opportunity to make a comeback when you look at the sustainability of the material. We've funded recently with CTBUH a life cycle analysis of buildings, and it's demonstrating that steel buildings are much more efficient for the environment over the entire life cycle of the building. So if we start looking at the entirety of the building and what we're going to do with it after it's no longer useful, if it's going to be demolished, steel solutions are a much better alternative to concrete.
Okay. Ken again.
My question is relating to the reinforcing bars of the concrete. Many years ago, we were talking about glass fibers replacing the reinforcing steel. And now today, we have carbon fibers. Is there anything that in the foreseeable future that can replace? I'm not talking about getting rid of steel. I'm talking about, is there anything that we have in the near future that can be more efficient than reinforcing bars, steel reinforcing bars?
That's a very good question. Unfortunately, I'm a little less familiar with that area, and I think that there's always a drive to make the reinforcing bars more efficient and higher yield strength than what's available on the market currently. So that obviously would be reducing the amount of material that's required. But aside from that, with carbon fiber reinforcement and glass fiber reinforcement, I'm not 100% certain how viable an alternative that is to reinforcing the whole of your building. So.
Hi, Jim Fortune. I have a question for Markus. On your system, I understand you have dedicated hoistways up and down. What happens when one of the cars fails in the hoistway and the other ones can't get by? Does it shut down the whole system?
Very good point, Jim, because this needs to be avoided by all circumstances. Of course, we will not have two shafts only in such buildings. We target this system, we will have multiple shafts. Sure, 4, 5, 6, or even more. So it would be possible in a worst-case scenario, to have just one shaft out of operation and continue operation in the remaining shafts. But we want to avoid this completely, because this would impact a building tremendously. So multi will be a very high availability system, and everything we do in design is going down the line that we don't accept any single failure to shut down the system. So if we have a partial system failure, we want to operate the system continuously. Of course, there are lots of scenarios. If we have then such a single failure, to replace this in off-peak times. We have the possibility to take out cars from the system and service them, something we don't have in conventional elevator systems. If we have a problem with a car today, we shut off this shaft for days and make repairs on cars or do changes on the ropes and things like that, causing a week or more to shut down a shaft. So in future, we want to be much better. And along with this, we want to even extend our efforts in predictive maintenance. This is what we do at the moment already for conventional elevators, but we want to go even higher to make sure that we find problems ahead of any breakdown, because multi relies on a very high reliability, and so you touch really a core of our product development and where we focus on.